Welcome, this is Odumat. Today I want us to look at trigonometric identities. Trigonometric identities. And for trigonometric identities, we are going to talk about how they behave when this is equal to that and those things. But before then, let's look at the Pythagoras theorem just in summary. So, if I have my right angle triangle, and let me call this side A, B, and then C. So we all know that the square of the hypotenuse is equal to the sum of squares of the other two sides. So that is A squared is equal to B squared plus C squared. So this is what we are going to use to look at the identities. Okay, so now let's look at this unit circle. It is unit circle because the distance from the center to the circumference is 1 unit. So the point here is 1, 0, because on the x-axis, y is 0. Okay, so that applies to the rest. Okay, now let me get a point on the circumference, and then the distance from that point to the center is also 1 unit. So here, let me call this point x, y. Okay, now I can bring this, trace it to the x-axis, and then also, okay, now the distance from here to here is x, and that's from this point to this point is also y. Let me get an angle called theta here. Okay, now let's look at this. We've drawn a line from this point to the x-axis, and that's a very straight line. So this is from the distance from here to here is x units. Okay, and now this is forming a right angle triangle. Okay, now let's look at this right angle triangle here. So I can say 1 squared is equal to x squared plus y squared. Okay, and which subsequently becomes x squared plus y squared equals 1, because 1 squared is 1. Okay, now our sine theta. Okay, so sine theta, sine is opposite over hypotenuse, which is opposite, which is y over 1. Y over 1. Okay. Then our cos theta. Cos theta is also adjacent over hypotenuse, so which is x over 1. Okay. Then our tan theta. Tan theta, tan is opposite over adjacent, which is y over x. Okay, now let's look at the reciprocal identities of trigonometry. That is for the sine, cos, and then tan. So for sine, it is cosec. So cosec theta, that is 1 over sine. So 1 over sine theta will become, we'll turn this upside down. That is 1 over y. And then for cos, which is sec theta, and that is 1 over cos theta, and means that that is also going to be 1 over x, because it's just 1 over x, which is the same as 1 over x. So it's just 1 over x over 1, because cos theta is x over 1. So 1 over x over 1, which is the same as 1 over x. Then the last one is, cot theta, which is 1 over tan theta, and that is going to give us, that is 1 over y over x, which is the same as x over y. So here algebra is just like y over x, 1 over y over x, and 1 is divided by y over x, which is going to be x over y. Okay, now let's look at sine theta, cos theta, and tan theta once again. So we said sine theta is equal to y over 1. Okay, so this implies y is equal to sine theta, because y over 1 is the same as y, or we can multiply with cross multiplication. 1 sine theta is sine theta, or 1 times sine theta is sine theta. So y is equal to sine theta. Then cos theta. So cos theta, we said that is also x over 1, which also implies that x is equal to cos theta. That is when you multiply both sides by 1 or you divide x by 1, you are going to get x to be equal to cos theta. Then that's of tan theta. Tan theta, here we have y over x. So let me put it here, y over x. Y over x. But we know that y is sin theta and x is cos theta. So in this case, tan theta becomes sin theta over cos theta, and this is our first identity number 1. Okay, now let's look at where we derived 1 squared is equal to x squared plus y squared, which we said is equal to x squared plus y squared equals 1. So x squared plus y squared is equal to 1. Okay, so we know x to be cos theta and then y to be sin theta. So we can say that this is cos squared theta plus sine squared theta equals 1. And this is our second identity. Now, let's divide through by cos theta and see what happens. We are going to divide through by cos theta. So, sorry, cos squared theta. So, cos squared theta here. Then cos squared theta also here. Cos squared theta. Okay. Now, this is going to be cos squared theta over cos squared theta, which we know it to be 1, plus this is sine squared theta over cos squared theta. And sin theta over cos theta is tan. So we can put tan here. So tan squared theta. So tan squared theta equals 1 over cos is sec squared. So that is sec squared theta. Another identity. So 1 plus tan squared theta is equal to sec squared theta. This is another identity. Now let's take the same second identity, which I said is cos squared theta plus sine squared theta equals 1, and divide through by sine squared theta this time. So sine squared theta here, sine squared theta here, and then sine squared theta here. Okay, so we can say this is to be cot, because cot theta is 1 over tan, and that becomes x over y, and our x is cos theta and y is sin theta. So we can look at this and say this is cot squared theta plus 1, and that is going to give us 1 over sine is cosec. So cosec squared theta. This is another identity. Okay. Okay, so let's look at one example or some examples and see how we can apply these when we are told to solve questions involving the identities. Okay, now we are told to show that, into brackets, sec theta plus tan theta, and then under brackets, minus 1 minus sin theta is equal to cos theta. Let's see. And when the question of this nature is given, you can decide to start from this side to see whether this will give you this, or you start from this side to see whether this side will also give you this one. Now let's see. So looking at the nature of this question, I prefer starting from this side because it will be difficult to get from here and then get an answer in this manner. Okay, so let's look at the easiest side. Now we know that sec theta is equal to 1 over cos theta. Then we also know that tan theta is equal to sin theta over cos theta. Okay, so now let's just substitute. So the opening bracket, sec theta is 1 over cos theta plus tan theta is this one, so that is sin theta over cos theta. Okay, then 1 minus sin theta. So we want to see whether this will amount to this one. Okay. Now let's see. Here the LCM is cos theta. So we can say that this is the LCM here is cos theta. So this is 1 plus sine theta. So when you have something like a over b plus c over b, you can write it as a plus c all over the LCM b. Okay. So now let's continue. Okay. So this side is giving me this, and they are multiplying 1 minus sine theta. Okay. Okay. Now here we can. This is having a denominator 1, so we can, when you multiply the denominators, that is going to give us cos theta. Now let's expand, or let's multiply the numerators. So 1 times 1 is 1 squared, so 1, or let me say 1 squared. Then 1 times negative sine theta is minus sine theta. Then sine theta times 1 is also plus sine theta. Then sine theta times negative sine theta becomes minus sine square theta. That is sine theta times sine theta is sine square theta. Okay. Now from here, these two can cancel themselves. And then we have 1 squared minus sine square theta. Okay. So this is 1. Okay. Now we can say that from the identities that we did, the second identity, which we say cos square theta minus plus sine square theta equals 1. So let's continue from here. From this identity, we can say that cos square theta is equal to 1 minus sine square theta, which we are seeing in the question. So we can see it from here that 1, this is 1. So let me clean this too, because it's still 1. So 1 minus sine theta is the same as cos square theta. Okay. Since 1 minus sine square theta is equal to cos square theta, we can say cos square theta over the LCM, which is cos theta. Okay. Now we can put this as cos theta times cos theta all over cos theta. So 1 will cancel itself, one of them, and then the answer becomes cos theta. So it means that we've been able to show that the question given is equal to cos theta, and that is true. Let's look at one more example. Now let's look at this example also. So verify the identity sec theta equals sine theta into brackets tan theta plus cot theta. Okay. Now what is on the board? Let me choose considering this side, or working from this side. Okay. So sine theta into brackets tan theta plus cot theta. Okay. So I'm going to work from this side. Now we know tan theta to be sine theta over cos theta. Then we also know that cot theta is equal to cos theta over sine theta. Okay. Now let's substitute. So sine theta into brackets sine theta over cos theta. Okay. Then plus cos theta over sine theta. Okay. So we can look at the LCM in the brackets. So that is going to give us, so sine theta outside, this is going to be cos theta times sine theta. Okay. Okay, now let's look at the numerator. So let's look at simple algebra. Cos theta into the denominator, this will cancel this and we'll get only this one. So sine theta times sine theta becomes sine square theta plus, now sine theta into this, we'll divide into this one and we'll get this. So cos theta times cos theta is also cos square theta. Okay, now from here, we know that sin square theta plus cos square theta is 1. So let me straight away do it. Now this is going to give me sin theta into brackets. This is 1. So 1 over cos theta sin theta. Okay. Now from here, we can expand or multiply. So this is going to give me sin theta over cos theta sin theta. Let me continue from here. Sin theta into brackets 1 over cos theta sin theta. Okay, so I'm expanding. So this is going to give me sin theta over cos theta sin theta. Okay, now looking at this, we can see that sin theta will cancel sin theta here, and we'll get 1 over cos theta, and 1 over cos theta is sec theta. So it means that sec theta is really equal to this side. Okay, now thanks for watching. We'll meet in the next lesson. Please don't forget to subscribe, like and share this channel. Okay.